Today, we're going to talk about a story that starts with, of all things, twitching frog legs in a kitchen, and it ends with the very device you're probably watching this on. This is the wild story of the world's very first battery.
It seems like a ridiculous question, right? But I promise you, the answer connects a bizarre scientific mystery from the 1700s directly to the batteries that run our entire world today. So yeah, let's get into it. So at the end of the 18th century, the scientific community was split by this huge debate. On one side, you had this guy, Luigi Galvani, who was convinced that animals created their own special kind of electricity. But on the other side was Alessandro Volta, and he was arguing, no, the electricity is coming from the metals you're using. And this little disagreement, well, it was about to change everything.
To really understand Volta's brilliant breakthrough, we have to start where he did, with the star of the show, a twitching frog.
Okay, so picture this. Galvani, an Italian physician, is doing some experiments. He's got a frog's leg with a brass hook in its spinal cord. When that hook touches an iron railing that the leg is also touching, the leg just convulses, violently. So what's his conclusion? It must be the frog itself. It had to be the source of the electricity.
The whole discovery was pretty much an accident. At first, he saw a spark from a nearby electrical machine cause the twitch. But the real mystery started when the leg twitched without any machine around, just with those two different metals. He thought he'd stumbled upon the secret of life itself.
And this is where Alessandro Volta comes into the picture. He reads about Galvani's work and just thinks, hang on a minute. He had a hunch that the frog's leg was just acting like a really sensitive detector for electricity, and that the real source was some kind of chemical reaction happening between the two metals, and he was determined to prove it.
So this brings us to Volta's absolutely brilliant and, honestly, super elegant solution. It was an invention that would not only settle the debate for good, but would kick off a whole new era in science. To prove that you didn't need the frog at all, Volta created something that was just beautiful in its simplicity. He basically built an artificial frog leg. His device, which he called the Voltaic Pile, was nothing more than a simple stack of repeating disks. So let's break down how this genius thing worked. Volta took a disk of zinc, then a disk of copper, and he separated them with a little piece of cardboard that was soaked in salt water. That's it. That's one cell. And here's the crucial part. He realized he could just keep repeating the stack, zinc, salty cardboard, copper, zinc, salty cardboard, copper, over and over again to make the effect stronger. And this is what made it so incredibly revolutionary. See, other gadgets at the time could only produce a single spark of static electricity, but Volta's pile, it could generate a steady, continuous flow of electricity. It was, for all intents and purposes, the world's first real battery. Now, each little pair of zinc and copper disks only generated about 0.76 volts. To put that in perspective, a modern AA battery gives you about 1.5 volts. So it wasn't a ton of power on its own, but by stacking more and more of these cells on top of each other, Volta could create a much more powerful current. More layers meant more voltage. It's so simple and so brilliant. And this is what one of those early piles actually looked like. I mean, it's just this elegant little column of metal and cloth, but what it represents is this absolutely massive leap forward for humanity, a portable, continuous source of electrical power.
So Volta's invention didn't just end a scientific argument. It gave scientists a brand new, incredibly powerful tool, and they got to work with it immediately. Almost overnight, the Voltaic Pile became the must-have new instrument in every serious lab across Europe. It let researchers do things with matter that they had only ever dreamed of. It really was the birth of a whole new field, electrochemistry. And the pace of discovery was just breathtaking. In 1800, the very same year Volta announced his invention, a couple of scientists used a pile to split water into hydrogen and oxygen. Just a few years later, a guy named Humphrey Davy, using a monster 2,000-pair pile, started discovering new chemical elements one after the other. The impact was just immediate and so profound. I mean, before the Voltaic Pile, all of these elements were completely locked away inside chemical compounds, totally impossible to isolate. And then, all of a sudden, with this source of steady current, scientists like Humphrey Davy could literally tear molecules apart, revealing the fundamental building blocks of our world. So how do we get from this simple stack of coins and wet cardboard to the high-tech batteries we have today?
Well, the connection is surprisingly direct, and it really cemented the battery's legacy for centuries.
This fact is just staggering. For over 70 years, until the electric generator was invented in the 1870s, everything that was electrical, from the first telegraph systems to all those lab experiments, ran on batteries that were direct descendants of Volta's original design. It literally powered the first electrical age.
And that brings us right back to where we started, that fundamental principle, using a chemical reaction between two different materials to create an electrical current. That is exactly what's happening inside the lithium-ion battery in your phone right now. Of course, the technology is way more complex and efficient, but the family tree is unmistakable.
Really, the final key step was getting away from that messy, brine-soaked cardboard. Experiments with what they called dry piles, which used more of a moist paste instead of a sloshing liquid, led directly to the invention of the dry cell battery. You know, the classic AA or AAA batteries we still use all the time. So, from a twitching frog leg to a stack of coins to the global energy grid of today, Volta's invention really did change the world. It makes you wonder, doesn't it? As we're searching for new ways to store and use energy, what seemingly small, maybe even accidental, discovery happening today is going to power the revolution of tomorrow?